Hello and welcome back to Data Analysis and Visualization. I'm Jovita Christie, and in this video, we are going to talk about map projections and coordinate systems in GIS. So once again, this is in continuation of my previous two videos on GIS. So if you haven't watched those, then please open the Data Analysis and Visualization playlist and you'll find all these videos in sequence. So let's begin. Map projections and coordinate systems. Map projections and coordinate systems give GIS a way to accurately represent a round Earth on a flat surface, translating the Earth's arced three-dimensional geometry into flat two-dimensional geometry. This is very important that Earth is two-dimensional since it's round, it's circular, but we want to show that in a two-dimensional space, which is why map projections and coordinate systems are very useful. Projections and coordinate systems project spatial data. So that is to say, they forecast and predict accurate spatial positions and geographic scale depending on where those features are located on the Earth. Okay, so it's not always easy to do a projection, creating maps and all, because you have to decide, on a small piece of paper, how you are going to show something that is so big. That all that scaling is required, the exact location is required. So all these things, when you have to plot on a map, it's quite difficult. Although projection and coordinate systems are able to project most features rather accurately, they don't offer a one-size-fits-all solution. Okay, so it depends on the spatial data set that you have. You won't always have a one-size-fits-all solution, which means the solution that works for your spatial data set may not work for somebody else's spatial data set. If features in one region are projected perfectly at scale, then features in another region are inevitably projected with at least a slight amount of distortion. Okay, so if you manage to, project perfectly with the perfect scale features in one region, then you will most likely have some distortion in projecting features of another region. And this distortion is sort of like looking at things through a magnifying glass. You can see the object in the center of the lens very accurately and clearly, but the objects on the outer edge of the lens always appear distorted, right? If you're trying to look at a bunch of coins using a magnifying glass and you put all the coins, very close to each other, then the coin that's in the center of your magnifying glass is going to be magnified really well. But the coins that fall on the edge of your magnifying glass will be distorted. You might be able to see maybe some of them, you might be able to see them, all in a different shape, not a circular shape. So this is distortion, which is happening because one thing is very clear, and that's why the surrounding things are not clear. No matter where you move the magnifying glass, this fact remains unchanged. Similarly, you can't represent all features of a round world accurately and to scale on a flat map. It's the same thing. The magnifying glass is flat, okay, and the magnifying is almost similar to the Earth. And so that's why when you look at something, it depends on where you look at, okay. Actually putting a bunch of coins on a table and removing the magnifying glass and just looking at those coins will make you realize that those coins are just ordinary coins and they are on a flat surface and you can see them very well. But then just taking the magnifying glass and using the magnifying glass to see those coins, it all depends on point of view then. Okay, which coin are you pointing your magnifying glass at? Similarly, if you were to just go up in space and just look at the Earth and try to look at your country from there, it would depend on where you are looking at from. Okay. From your point of view, the country might look different than somebody else's point of view who's also up there in space. So it all depends on where you're looking at from. So if you manage to plot something very accurately and scale it also very accurately, then other things are going to get affected and they may not be so accurately scaled on a flat map. In GIS, the trick to getting around this distortion problem is to narrow your study area. Focus on only a small geographic region and use the map projection or coordinate system that's most accurate for this region. Okay. Do not try to put a huge area. Do not try to create a map system for a big area. Try to focus on a smaller region because the smaller the region, the better you'll get the output. And for particular regions, you will also get a particular map projection or coordinate systems already available for you. So if you have a region in mind, just look for such a map projection or coordinate system which is available and then use that. Coordinate systems are referencing systems that are used to define a feature's location on Earth. Okay, coordinate systems are referencing systems, which means, latitude, longitude. You can refer to a feature's location on Earth. Okay, and there are two types of coordinate systems. We're going to see those now. The first one is projected coordinate systems, also called map projections. Projected coordinate systems are mathematical algorithms that you can use to transform the location of features on a round Earth to equivalent positions represented on a flat surface instead. Okay, and the three most common projection types are cylindrical, conical, and planar. Okay, so map projections, which are projected coordinate systems, they are also sometimes called map projections, and this allows you to represent features of locations which are available to represent location of features which are on a round shaped Earth on a flat surface like a map. And it's quite accurate. And to do that, you have to use three types of projections, commonly used projections, which are cylindrical, conical, and planar. The next type of coordinate system is known as geographic coordinate system. And this uses a set of numbers or letters to define every location on Earth. In geographic coordinate systems, location is often represented by latitude, longitude, decimal degrees, or degrees, minutes, seconds, if you're familiar with old-fashioned surveying nomenclature. So in old-fashioned surveying nomenclature, people used to use degrees, minutes, and seconds. They used to use decimal degrees. Nowadays, people are more used to latitude and longitude. So latitude and longitude are geographic coordinate systems, and this is how you can show your data, which is show a location that's on Earth on a flat surface of a map. So this is just an example of what it looks like. If you have cylindrical surfaces, this is what it looks like. I remember I mentioned that in map projections earlier. And you have three types: cylindrical, conical, planar. So this is what it looks like. You can see how the Earth, round surface of the Earth, is fitted inside. Now that you know what types of coordinate systems are out there, it's time to take a look at how you'd make practical use of them. And this is the easy part. In almost all cases, when you import a spatial data set into GIS, it comes in with its own predefined coordinate system. And the GIS software then adopts that coordinate system and assigns it to the entire project. So that's easy because every data set that comes into GIS usually has a coordinate system attached to it as well. We're going to see that with an example in one of the later videos. So the GIS software just has to adopt to that coordinate system that is already available with the dataset, and it just assigns that to the entire project and you're good to go. So it's very easy. It's as simple as that. when you add additional data sets to that project in the future, they may be using the same coordinate system or an alternative one, which is quite possible. So in cases where the new data is coming in with a different coordinate system, the GIS software will transform the incoming data so that it is represented correctly on the map. Okay, so if you have a running project that you're doing right now and you have that project using a certain coordinate system, but then you get new data and that new data is having some other coordinate system, but you want to use that in your project, then you just have to get it into the GIS software and it will automatically transform that into the coordinate system that is used in the existing project so that it can be represented correctly on the map. So the software basically does everything for you. You just have to figure out which button to press. So as an example of how all this works in practice, to determine how much agricultural land has been contaminated during a tanker spill at the Mississippi Delta. Okay, so this is an example of a tanker spill. So that tanker could be containing some poisonous substance and it's an agricultural land, okay? And because the tanker, there was a tanker spill, the agricultural land is now contaminated in Mississippi Delta, which is an area, okay? So you import a data set, a spatial data set, which is called contaminated land, okay? Now this contaminated land file already has a predefined coordinate system, which is the state plane coordinate system, Mississippi West. I'm not going to read out the whole thing. So, okay, West MS underscore W 4376 and 2302. So these are, this is the name of the coordinate system that is already assigned to this file called contaminated land. It's a spatial data set. It has this coordinate system already assigned to it. Now, when you import the dataset, GIS automatically detects that there is a coordinate system assigned to this spatial dataset. Okay, and it automatically assigns that system to the entire project that you have started. And it will transform any subsequently added spatial datasets so that they come in with correct scale and positioning. So it's that easy. Because you started with a certain coordinate system, if you have more data coming in with a different coordinate system, it's just going to apply the same one to those new spatial data sets as well. Information about a dataset's default map projection and coordinate system is stored in its metadata description. The default map projection and coordinate systems are the fundamental reference systems from which you can reproject the dataset for your specific needs. So I hope you got a clear idea of what map projections and coordinate systems are like. And in the next video, we'll see a little bit further in GIS, how to analyze, specifically how to analyze the GIS dataset, because just like we use a DBMS or a database management system or a relational dataset, the main purpose is not just storing the data and not just storing the data properly. It's also about retrieving the data, manipulating the data, right? You are not just able to perform create and insert queries. You also want to do select, you want to do update and delete and insert. So you want to do all these queries at the same time. So we are going to study how you can analyze the spatial data set. This was all about creating a spatial data set or sort of importing one into your software. But once you've done that, now how do you analyze such a data set so that you can get useful information from it? That's what we are going to be seeing in the next video. So I'll see you there and thank you for watching.